All right, so welcome to the best class on arrays that you'll have this entire recording whenever you watch this. So today, a couple of notes before we get going. First things first, if you've noticed how the homeworks are set up, they kind of build on each other, right? There'll be a chunk of a problem, then a bigger chunk, and then one that kind of puts it all together. I have it set up like this because that's how I want you to approach your codes. It's like I said before, it's very hard to wrap your head around a whole question at once. So I want you to take a problem, break it down into its smallest chunks, and kind of go from there. So, for example, with the esteemed Catalan number generator. So you have this number like 5 on the homework, right? Or 4 on the homework. So a Catalan number is 3 different factorials that you compute, then do some math with, right? So in order to write a Catalan number generator, the first thing to do is break down the problem. Say, okay, the problem asks for a whole bunch of Catalan numbers. All right, well, can I make a Catalan number? Okay, what is a Catalan number? Well, it's 3 of these factorials multiplied and divided together. So what I want to do first in that scenario is to make a program that can compute a Catalan number, then a program that can compute 2 different Catalan numbers and do math with them, like multiply them together or divide them. Then when it comes time to, sorry, I didn't mean Catalan numbers, I meant factorials. A program that computes 2 different factorials, then does math with them, multiplies them together or divides them. Then I can take that same code, just add and just copy one more of those factorials down and say, well, now I can get the 3 factorials I need to make a Catalan number, do all the math I need to do with that. And when it comes time to make a sequence of them, then okay, I have this thing that generates a Catalan number. Now I just have to put it into a loop or something so that it can do that so many times. That's how I'd want you to approach a code. Break it down into its smallest parts, go from there. The goal here, this is what I was kind of trying to say in the Zen of Python stuff that I sent around, is that you want to start in simplest terms. You don't want to start complex, you want to start simple. So what's the simplest way to approach a problem? What's the simplest statement of the problem, if you will? So that's how I would encourage you to go about it. Similarly, a bit of encouragement with the one of the other statements on there. In the face of ambiguity, refuse the temptation to guess. If something's not working the way you think it should, just go line by line through the code. Not necessarily just reading it, although it is good to proofread your code, math errors and all that kind of thing. But say, okay, X is 1 up here. Okay, in this line, X becomes 5. Okay, in this line, I start a for loop. Okay, this variable's this. Go through and look at how each of your variables change as you go through your code. Another good way to make sure that you know what's happening. Because my impression with where a lot of folks are at is that you know how to use the different parts of speech, if you will, in Python. You know how to set things equal to one another, how to do math, how to write an if statement, how to write a comparison or a for loop or a while loop. You can write them. The disconnect is in taking what the problem is, what the problem statement is, the thing you're trying to solve, and translate that into Pythonese, if you will. So don't feel bad about it. You're in a really good spot for where you are. Remember, this is like week 3 of knowing anything about Python for many, if not all of you, right? So the rest of that connection between the concept that you're trying to solve and your knowledge of coding, the kind of the bridge between that comes with practice, lots of practice. So don't feel bad, you're in a good spot, and we're going to do some more practice today. So today we're going to work on loops, but we're going to do it in the context of what's called an array. So an array is a specific type of variable. If you think of the variables we have used right now, it can set like x equal to 5, right? Well, 5 is the only thing that's stored in x. I can put one thing into x. Great. But think of different data sets that you might want to use coding to work on. Excuse me. I use the example of like a stream data logger in class. You have a probe sitting in the stream monitoring pH, pressure, flow rate, all these kinds of things. And you monitor and you record one data point every hour for 3 months. That's a ton of data. I don't want to be sitting here or writing variables for each one of those, right? That's where arrays come in. Arrays hold a lot of data out all at once, so it's a lot easier to manage. Now, if we have a whole lot of data to manage, we'll probably want loops to help us move automatically through a big set. So we're going to talk about arrays today, but hopefully, my hope for this is that it gives you a sense of how to think about implementing loops. All right. So arrays, as said, the usual variable only holds one piece of information. Array holds a lot of information. So for today, we're going to not create our own arrays. We're going to get data and then do some math. We're going to do that with something called the load text command. This is a command found in the Numpy library. So that Numpy there, that's the library dot the command. Okay. There's a reference on how to use it here. I can read through the rest of this PowerPoint. There's kind of a reference and everything we talked about embedded in it. But let's just go ahead and see if we can't put it into practice in Phone. First things first. If you go on to Canvas, here we go. Want to go on Canvas, scroll down to the bottom of the page here, get loops and array module, and download both the streamflow data and the NREL data. Okay, we're going to be working on the NREL data in class, so make sure you download that, and most importantly, make sure that you save this text file in the same place where you save your Python scripts. If they are not in the same place, your code will not work. Make sure you save this file in the same place that you're saving your Python scripts. If you don't, this code will not work. Okay? All right. So once you got that, it should look, if you open it up, it should look something like this. This is sourced from a National Renewable Energy Laboratory experiment, NREL. It's for a wind turbine. It's for a newer type of wind turbine, at least at the time. The left-hand column here is the wind speed going through the turbine in meters per second. The right-hand column is the power produced by the turbine in kilowatts. So two columns of data have these nice headers that tell us what's in them. Great. All right. So we want to read this into Python. Let's just do something simple with it. We'll just take this column of power data and convert it into megawatts. Right now it's in kilowatts. We want it in megawatts. We just have to divide by 1,000. Right. All right. So just want to read this data set in. Take the right-hand column here and could say the right-hand column here and divide everything in that column by 1,000. That's our goal. All right, so how do we do this? So I'm going to pop over into Bonnie here. That's the finished example from class, pardon me. Change the settings. So I'm going to set up a new file here. This is a load text example. All right, so load text was in the Numpy library, right? So in order to use it, I have to first load the Numpy library. So I do that always at the top of the code. I mean, it'll work anywhere, but best practice, do it first thing right at the top. So you always know what libraries you have in your code. So I'll do it right here. I'll say import Numpy. So that pulls in my Numpy library. Then I can access commands in that library by typing the name of the library dot command. So same as here, name of library dot command. However, I don't feel like writing Numpy 1,000 times. I'm a little bit lazy. So I'm going to say import Numpy as NP. That lets me use NP instead of Numpy. It kind of renames the library. All right, so I have the library. All right, so now I'm going to use it. So I'm going to write the right-hand side of this command first, followed by the left-hand side. So equal sign there, right-hand side first, then I'll write the left. So first is command np.load text. Great. If I look at my thing here, this is how to use it. So anything inside these square brackets are optional. So all this I don't have to use. I can if I need to. We'll talk about that later on. The only thing I need to do is tell the load text command the exact file name of what I am trying to do, of what I'm trying to load. So so the exact file name, if I pull open, okay, so I have my text file right here. NREL data.text is the complete file name. NREL_data with capital D .txt. If you cannot see the file extension, that .txt, go up to the top of your file explorer, hit view, go over to the box that says file name extensions. Make sure that it's checked. If it's not checked, you will not see the complete file name. If it is checked, you can. So make sure it's checked. Once it's checked, you should be able to see nrel_data.txt. That's the complete file name. So when I come over to Fawny, I'll say quote nrel_D data.txt. It's all in quotes because it's a name, it's a word. I can close my parenthesis, come over here, I'll make up a variable name, nrel data. All right, great. All right, so that's the simplified version of command. And if I run this, it will, after us asking to save it, and then it will, wait for it, takes a little bit to load the first time. It'll blow up. Got a big nasty error here. All right, so how do I do this? How do I read this? Well, the actual error is at the bottom. It's a value error. Could not convert string to float. All right, we'll get to that in a second, but where did this come from? So I don't know what this line is. It does not seem familiar. Actually, this is what you're seeing is exactly where the error came from. The error actually came from inside of Numpy. So all these blue things here are things in Numpy. If you look at the file path here, it's in some obscure place on your hard drive. I'm just going to scroll up here until okay, downloads. I know where that is. Hey, that's name of my Python script. Hey, it's on line 9 of that script. Okay, it's right there. That's where the problem is. So that's how I can read this. Now, if I come back to this value error thing, it's saying it cannot convert a string to a float. All right, so let's think about this for a second. We said first day of class, a float is a number with decimals, so it can't convert whatever it is to a number with decimals. A string, we briefly mentioned, is anything that's not a number. It's words, it's anything else like that. So if I look at my text file, oh, I have things that aren't numbers in here. This is one of the limitations of the load text command. Numpy, or the numeric Python library, is a numeric library. It can't deal with words. It can't deal with things that aren't numbers. So it can't load all this stuff or all this stuff because there are words and non-numeric stuff in it. So we're screwed, right? Like, shoot. Well, the folks who made this figured that people would have to deal with this, so they made a way to get around loading the non-numeric stuff. If I look at my PowerPoint here, one of the optional arguments is the skip rows command. So what skip rows lets us do is skip rows from the beginning of the text file. So in this case, if I just skip these first two things, which are really nice because it lets me know where my data came from and what the units are for each column. I don't want to delete them. They're things that are good to have in the file. I just can't load them into Python. If I tell load text to skip these, the rest of this file is numeric, no problems. So if I go back into Thonny, I can tell it, comma, skip rows. I want to skip the first two rows. All right, and for kicks, I'll print out my variable. So run that. All right, there I am. So there's all of the data from my text file. It's all now loaded into that variable. Awesome. I'm one step closer to being able to do math on this. Next question is, okay, I have all my data there. Now I only want to mess with this column of it, right? I only want to mess with the power. I just want to convert that from kilowatts to megawatts. That's it. So how do I get to just that column, right? So if you look at this, it's in a grid, right? Like I have my first column here, my second column here. It's very ordered, structured. There's kind of a place for everything, and everything is in its place. It's exactly what it is. I can think of it. This is all the data from that file. I can think of an array, which is what that variable is called. It's called an array, as a grid of my data. So the first data point in my array, I can put these side by side. So the first data point in my array here, that's my first spot in my grid. Got over here, right there. And also, not only is it structured, but because it's structured, it's in a grid, means that every data point has an address associated with it. It's kind of like Excel. Like here I have my Excel sheet. This guy is 1, 1. This guy is 1, 2, 2, 1, 2, 2. There's an address for every single data point here, right? Well, in Python, we have that same thing. The numbering scheme is just a little bit different. So blow this up for a second. Move this over here, move this up. So in Python, the first row is 0, first column is number 0. So column 0, column 1, row 0, row 1, row 2, row 3, row 4, so on and so forth. So the address of this first guy is 0, 0. The address of the second guy is 0, comma, 1. Address of this guy is 1, comma, 0. And so on and so forth. Like this guy would be 2, comma, 1. Okay? Very, very similar to Excel. The difference, and this is what's going to get everyone, so make sure you keep this in mind. The row number starts at 0. The column number starts at 0. So the first row, first column is 0, comma, 0. Okay? That's where it starts. Keep that in mind. It's going to come back. And it's going to bite you, and it's going to bite you if you don't keep it in mind. All right? All right, so I know where all these things are. Now I just have to access them, right? So if I go back over to my code, say I want to print out this guy. I just want to print that one data point. So this guy, it's in the second row, which means it's in row number 1. And it's in column number 0. So if I want to print that one, I type in my array name, square bracket, row number, comma, column number, close square bracket. All right, name of array, square bracket, row, comma, column, close square bracket. So if I run that, bam, there it is. I asked for second row, first column, or row 1, column 0, to be 2. There it is. Bam, we've done, gone, did it. All right, so that's great. And if let's get rid of this. So let me put some comments in here. Load up NRL turbine data. First column is wind speed in meters per second. Second column is power output in kilowatts, so I know what's what. Power data from. So if I wanted to do this, I could say power megawatts, sorry, power kilowatts. There's NRL data. Let's just get the first one. So that'd be what? The first row. So it's row 0, column 1. That's my first power data point. And then I can convert that into megawatts by divided by 1,000. Then I can print it, right? That gets me one data point. If I run that, well, it'll be 0. But if I want to, so that's 0. If I want to go to the next row, just increase that by 1. Next row, increase that by another 1, so on and so forth, right? And you see, if I look on the 1, 2, third row, so row 2, it's 47 kilowatts or 0.047 megawatts. It's doing what it should. So 47 has the address of 2, comma 1, column 1, row 2. There, we should call that. That's the data point that comes up when I access it there. Then save that to a variable and do math. Awesome. That's it. I can shorten this a little bit. This is 47. Like that is that particular data point. That this guy here is that, right? Like that's the array and that's the address of that particular data point, right? So NREL data bracket 2, comma 1, that is 47. So I can do math on it the same way that I would any other variable. So I can go something like that, cut out the middleman, and converts straight up. Awesome. Makes my life a little bit easier. What doesn't make it easier is that I have to change this thing in order to get to each data point, right? It'd be really nice if I could automate that. Well, think about that for a second. What would do it? I need to change this number one by one from 0 to some higher number. How can I do that? Well, one answer, well, if I think of like a for loop has a loop variable in it, right? And the for loop changes the value of that variable from 0 to some higher number. It sounds like exactly what we're looking for. So if I come up with it here and say for I in range, I don't know, I'm just going to say 10 for right now. The value of I, it starts at 0 and it goes to, in this case, 9, right? Well, that's kind of what I want. I want this row number to go from 0 to some higher number. So I'm just going to put I in there. And if I run that, and wait a second, there we are. It went. It's if I go through this line by line. First time I'm on row 14, I is 0. So when I come down onto row 15, this is accessing NRL data 0, 1. So first row, second column, great. I pull out that data point, divide by 1,000. That gets saved over in here, print it out. Great. Come back up to the top here. Value of I is now 1. Okay, now I'm looking at 1, 1. Divide by 1,000, print it out. Come back up to the top. I is now 2. This is now 2, 1. 2, 1. Divide whatever that data point is by 1,000. Save it as power megawatt, print it. I is now 3, and so on and so forth. You see how the loop is automating our array access. Yeah, it's because we can use the loop variable to move us through the different rows of the array. Awesome. So this is good. Problem though, will this, as it is written, access every element in my data set? The answer is no. If I look at my data set, I count this up. I have what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 rows here. I'm only going through 10 data points here. It's not going to be all of them. And if you think of like the stream data that I mentioned earlier, you have thousands of data points. I'm not going to count them. Forget that crap. I want Python to do it for it, to do it for me. So so thankfully there's a way to do it in Python. It's called the size command. So again, do this the same way that we did the load text command. I'm going to write the right-hand side first, then we'll write the left-hand side. So this equals np.size, open parenthesis. So whatever variable I put into this parenthesis is what the size command is going to tell me the dimensions of. So I want to know I want to figure out the number of rows in NREL data. So I'm going to put n NREL data. Then specifically, I want the number of rows, right? So in order to specify that, you say comma 0. What you put here, what number you put here, changes what dimension it will tell you. Put a 0, that's rows. 1 is columns. 2 is the depth. 3 is whatever fourth dimensional thing you are making. You can make an n-dimensional array. But what number you put there changes what np.size tells you. So in this case, it's going to tell me how many rows are in NREL data. All right. I'm going to save that as a variable n rows. Well, if that's the number of rows that I got, well, put that into there. And if I run that, well, that looks like all of them. Sweet, that looks like all of my data points. I want to be confident about what n rows is. I can have it print that out too. There we go. N rows is 14. So there's all 14 of my rows here. Looks like they're all converted to megawatts. Great. I am all set to go. That's the gig. Hope that helped you out a bit. Couple of notes here before we finish up. Just going to, +1 there for kicks and giggles. A common error when you use arrays, something called an index error. So let's parse this. So the loop worked. It threw out a lot of good data, and then it threw this error. This error came up on line 616. So while it was computing this, the error is index 14 out of bounds for axis 0 array size 14. All right, what that? Okay, so some notes. Excuse me. These things that you use to give an array address, these are called indices. Each one is an index. These are the array indices. So index 14, presumably, I mean, I don't have a 14 written in here, so 14 probably came from that I there being 14. So that I became 14 at some point. It's out of bounds. Okay, well, we'll get there in a second. It's out of bounds on axis 0, which has a size of 14. So axis 0, if I remember my size command, 0 corresponded to rows. So it's saying that I tried to get row number 14. Sorry. Hang on a second. There we go. This error is saying tried to access row number 14, but there are only 14 rows in the array NREL data. That's what it is trying to say here. Oops. Nope. Just trying to get that far. Hang on, I don't think I'm going to be able to do it. Okay, so I tried to access this row number 14, but there are only 14 rows in the array NREL data. Well, what the heck? There are 14 rows in NREL data. Shouldn't there be a row 14? What's going on here? Well, the problem is, well, the misunderstanding is that there are 14 rows in NREL data, but the first row, its address is 0. So if I count down here, this is row 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Python's throwing a fit because I'm trying to access row 14 and there isn't a row 14 in this array. There are 14 rows, which means the highest row address is 13. So it's saying it's not there. I can't do anything for you. That's what an index error is. So that's that. There was a question in class, what happens if I make this 1? Well, now it's columns. So if I print out n rows, you'll see that n rows is now 2. That's now how much size is now telling me how many columns they have. So I put 1 in. I'm also trying to access. Whoops, but I didn't switch these up. There we go. I was still accessing rows. So now I is changing my column address. So if I run this again, I'll be on the second row, row 1. column 0 and column 1. All right, so that's that. That's kind of the basics of arrays, and using loops to mess with them. Hopefully that gave you a little bit better handle on how to think in loops in Python. This up on Canvas, and I'll see you when you're back.